Welcome back to the fourth lesson on geometric optics, and in this lesson I would like to discuss the ray diagrams that we use as light moves from one optical medium into another, as well as Snell's law. So to draw a ray diagram we need a ruler and a pencil, and we need to be, in some cases, accurate, using our protractors to measure angles. In some cases we can just be neat. So light is moving from an optically less dense into an optically more dense medium. What will happen to the light? If it moves from a less dense medium into a more dense medium, the light will slow down. And if it slows down, it is bent towards the normal. So let's make a sketch. There is the surface. It should be a straight surface to make life easier, between a less dense medium, optically less dense medium, and a more dense medium. So this is optical density. So first thing we have to draw in is our normal. Normal would be 90 degrees to the surface separating the two mediums. Second thing we will do is draw in the incident ray. Now this could be confusing because when we discussed reflection of light we also mentioned incident ray, and we mentioned the angle of incidence, and we said that the angle of incidence is always measured between the incident ray and the normal. So here we go. This is the angle of incidence. But in this case, most of the light will not be reflected from the surface between the two mediums. It will move into the medium. Now it's moving from a less dense medium into a more dense medium, so the light will slow down. When it slows down, it bends towards the normal. So this is now not our reflected ray, but our refracted ray. And the angle between the refracted ray and the normal is not called the angle of reflection, but the angle of refraction. So this is the ray diagram where light moves from a less dense, optically less dense to an optically more dense medium. And your angle of refraction is smaller than the angle of incidence. Secondly, a ray diagram where the light is moving from an optically more dense into an optically less dense medium. So what is different? Difference is now the light will be moving from the optically more dense medium into an optically less dense medium. So in this case, the light will speed up. It will go faster from a more dense into a less dense medium. Once again, we need to draw our normal in, normal to the surface separating the two mediums. Our incident ray, with the angle of incidence shown there. Now when light speeds up, it is bent away from the normal. So this light will bend away from the normal and the angle of refraction measured between the refracted ray and the normal is bigger than the angle of incidence. So this is just a copied diagram where P is the angle of the incident ray, and for example, you have medium 1, refractive index N1, speed of the wave V1, medium 2, refractive index 2, speed of light in that medium V2. So here, instead of using theta I and theta R, they use theta 1 for the angle of incidence in the first medium and theta 2 for the angle of refraction in the second medium. Now here you can see that theta 2 is smaller than theta 1. That tells me that N2 is greater than N1. The optical density of the second medium is higher than that of the first medium. So V2 will be less than V1. The speed of light in the second medium will be smaller than the speed of light in the first medium. From here we're going to discuss Snell's law, which brings a mathematical relationship between the angle of incidence and angle of refraction and the velocity of, or the speed of the waves in the medium. So Snell's law, like refractive index, was a ratio between two speeds. Snell's law is a ratio between the speeds and the signs of the angle of incidence and angle of refraction. So the words are as follows. The ratio of the signs of the angles of incidence and refraction is equal to the ratio of the velocities in the two media, or equal to the inverse ratio of the indices of refraction. So in maths, sine theta 1 over sine theta 2 equals V1 over V2. Four things brought into a ratio. But V1 is actually C over N1. So I can write that into that equation and get the following. Let me do that step by step for you. Sine theta 1 over sine theta 2 equals C over N1 divided by C over N2. And if we do that, C over N1 multiplied by N2 over C, and the C's will cancel, so you get that ratio. So if we take that and we simplify it, we get N1 sine theta 1 equals N2 sine theta 2.